In the previous video, we explored system-level development in ISO 26262 Part 4. There, technical safety requirements were defined for the complete system. The next step is translating those system-level requirements into a safe hardware implementation. This is exactly the purpose of ISO 26262 Part 5. Product development at the hardware level. Part 5 focuses on designing, evaluating, and verifying hardware that contributes to functional safety. In this video, we'll explore the major activities within Part 5 and understand how they help create reliable automotive electronics. Before we examine the individual clauses, let's first understand why hardware development is such a critical part of functional safety. Modern vehicles rely on increasingly complex electronic hardware, microcontrollers, sensors, power electronics, communication interfaces, and many other components. If the hardware cannot perform reliably, even perfectly designed software cannot achieve functional safety. For this reason, ISO 26262 dedicates an entire part of the standard to hardware development. The objective is not simply to create hardware. The objective is to create hardware that supports the required level of functional safety. To understand how this is achieved, let's look at the structure of Part 5. Part 5 consists of 6 major activities. It begins with general topics that establish the framework for hardware development. Next, hardware safety requirements are specified. These requirements guide the hardware design. The architecture is then evaluated using hardware architectural metrics. Potential random hardware failures are analyzed. Finally, the integrated hardware is verified before development continues. Let's begin with the general framework that supports these activities. Clause 5 establishes the overall framework for hardware development. It introduces the principles that guide engineering activities throughout Part 5. Rather than defining specific technical solutions, it creates the environment in which hardware safety activities can be performed consistently. This framework helps ensure that safety remains an integral part of hardware development from beginning to end. With this foundation established, the first technical activity can begin. The next 2 clauses work closely together. First, hardware safety requirements are derived from the technical safety requirements defined at the system level. These requirements describe what the hardware must achieve. Next, engineers develop the hardware design that satisfies those requirements. Major hardware elements are selected. Interfaces are defined, and the overall hardware architecture begins to take shape. Once the architecture has been created, an important question remains. How robust is this design from a functional safety perspective? ISO 26262 requires organizations to evaluate the hardware architecture. The objective is to assess how well the architecture supports the required level of functional safety. At this stage, different architectural characteristics are analyzed to identify potential weaknesses. Rather than discussing the detailed metrics in this introductory video, it is enough to understand that the standard expects organizations to evaluate the robustness of their hardware architecture before continuing development. Another important aspect of hardware safety is the consideration of random hardware failures. Electronic components can fail, even when they are designed correctly. Some failures occur randomly during operation. Part 5 requires organizations to evaluate how these random hardware failures could affect the achievement of safety goals. The objective is to understand potential risks and ensure that the hardware architecture provides an appropriate level of fault tolerance. Detailed concepts such as hardware metrics and probabilistic evaluations deserve their own dedicated videos, so we will explore those topics separately in the future. Before hardware development is completed, one final activity remains. The final major activity in Part 5 is hardware integration and verification. Individual hardware elements are combined into the complete hardware solution. Verification activities then provide confidence that the integrated hardware satisfies its specified safety requirements. This represents an important milestone before the hardware becomes part of the complete system. Now that we've explored the individual clauses, let's see how they fit into the overall ISO 26262 lifecycle. Part 5 does not exist in isolation. It builds directly upon the technical safety requirements established during system development. The resulting hardware platform then provides the foundation for software implementation and overall system integration. Understanding this relationship helps explain why ISO 26262 separates development into multiple lifecycle stages. Before we finish, let's summarize the most important takeaways. Let's summarize the key points. ISO 26262. Part 5 focuses on the development of safety-related hardware. It begins by defining hardware safety requirements. These requirements guide the hardware design. The architecture is evaluated from a functional safety perspective. Random hardware failures are considered. And finally, the integrated hardware is verified. Together, these activities help ensure that automotive hardware contributes to the overall safety of the vehicle. This completes the hardware development perspective within ISO 26262. If you'd like to learn more, many of the topics we introduced today will be covered in dedicated videos. If you want to go beyond this introduction to ISO 26262, we offer comprehensive online training programs on our website. These self-paced courses cover functional safety concepts, ISO 26262 requirements, practical implementation approaches, and real-world engineering applications. The focus is not only on understanding the standard, the focus is on applying it effectively in automotive development projects. You can find the link in the video description and also in the pinned comment below. If you found this video helpful, please consider giving it a like and subscribing to the channel. We regularly publish content on functional safety, ISO 26262, ASPICE, ISO 21434, and other engineering standards. Thank you for watching, and we look forward to seeing you in the next video.